This is Miss Humbert here. Today we're going to be doing Unit 3 Notes 2, so we're going to be talking about adding and subtracting polynomials. So for starters, let's just take a look at adding polynomials. So when you add polynomials, you're basically combining like terms. And once you do that, you're going to write your answer in standard form. Now remember from Notes 1 that standard form means it needs to be in order of decreasing exponents. So your exponents go from largest to smallest, going left to right. So let's just take a couple of seconds and practice combining like terms. So remember that like terms have to have the same letter with the same exponents. So what I like to do when I'm putting things in standard form and finding like terms, I like to find the largest exponent, which is x to the third. So I notice that I have 4x to the third plus 3x to the third. So I can go ahead and I can add my coefficients. 4 plus 3 is going to be 7. And remember that you're not adding the exponents, so that's going to stay as x to the third. So I'm going to go ahead and cross that off. Then I have 8x squared minus 5x squared. That's my next highest exponent. So I'm going to go ahead and subtract those coefficients, and I get 3. And again, that's going to stay as x squared. I'm not adding the exponents. Next, I have negative 3x plus 5x. Well, negative 3 plus 5 is going to give me 2, and that's going to stay as x. Last but not least, 8 minus 12 is going to give me a negative 4. So my answers are combined, and they're in standard form. So let's go ahead and let's take a look at number 2. So for number 2, for starters, we have 7x cubed. Cross that off. Then I have 3x squared minus 2x squared. So I subtract those exponents and I'm left with 1. Now remember, if you have something like 1x squared, that you can actually just write that as x squared. You don't have to write the 1. So we can go ahead and cancel those out. Negative 7x minus 9x. Well, when you add two negative numbers, you're basically adding and getting more negative. So negative 7 plus 9 is going to give me negative 16. And again, I'm just going to keep that as x. Last but not least is I'm taking 9 plus 11, and that's going to give me 20 for my constant at the end there. So let's go ahead and let's take a look at different ways you can add and subtract. First of all is horizontally, and that's lining the terms straight across and combining like terms. That's kind of like what we did on 1 and 2, is we just combined like terms. Okay, but a method that I really like to use would be lining it up vertically. So you have a column for x squareds, you have a column for x's, and you have a column for constants, and so forth. The reason why I like this method more is because it helps you get it in standard form right from the beginning. So I do want you guys to pause the video and write this down, but ultimately you'll be picking what method works best for you. Okay, so let's go ahead, and this should actually be number 3, so the numbering's going to be off a little bit. So let's go ahead and take a look at number 3. So for number 3, what we need to do is let's line it up vertically. So for the first one, I have 3x squared minus 4x plus 8. Now I'm going to rearrange the second one to be in standard form. So I'm going to have negative 7x squared first, and then 2x squared, and then minus 5. So notice I have an x squared column, an x column, and a constant column. So now when I add down the columns, my answer will automatically be in standard form. So 3x squared minus 7x squared, well, that's going to give me negative 4, and then again, that's going to be x squared. I'm not going to add the exponents. Okay, negative 4x plus 2x, that's going to be a negative 2, and then that's just going to be x. Again, not adding the exponents. 8 minus 5 is going to give me 3. So then my answer is negative 4x squared minus 2x plus 3. So let's take a look at number 6. Let's add it. So we have 5x squared minus 3x plus 4. Again, I'm going to take that second one and I'm going to rearrange it so that I can line up my columns. So I'm going to put the negative 3x squared in the squared column, the 6x in the x column, and the negative 3 in the constants column. And now I can go ahead and add down. 5x squared minus 3x squared is going to give me 2x squared. Negative 3x plus 6x is going to give me 3x, and 4 minus 3 is going to give me 1. Again, because I use that vertical column method, it's already in standard form, which is great. Okay. Let's go ahead and let's take a look at this next one. So we have subtract the polynomial. So when you're subtracting the polynomials, you want to distribute the negative into each term in the parenthesis that follows it. Then you will combine like terms. Now, sometimes when doing this, students get a little lazy and they don't distribute the negative all the way through. If you'll notice, when this person did this, they distributed that negative all the way through. I do suggest physically writing that out simply because it gets very easy to forget by the time you get to the last one that it's a negative, okay, or that you're changing the signs. So pause the video, get that written down, and let's take a look at some of these practices. So first thing I'm going to do on these ones is to distribute that negative. So I'm going to change this to a positive, so I'm adding them, and then I'm changing the signs of everything. So I'm going to go ahead and write my column. So I have 4g cubed minus 5g cubed. So now it's going to actually be in this column a negative 2g cubed. Because we're subtracting, I had to go through and change those signs. And it's going to be a minus 4g. And now I'm ready to add down the columns. 4g cubed minus 2g cubed is going to give me 2g cubed. Negative 5 minus 4, again, that's going to get more negative, and I'm going to get negative 9g. So that's my final answer for number 7. Taking a look at number 8, I want to distribute that negative in. So I'm going to write my columns. I have 3n squared. Oops, I have n cubed first. Again, putting it in standard form. So I have 13n cubed plus 3n squared plus 5n. So now I have a negative 7n, so I'm going to add that to my n columns. And then I have a negative 4n cubed, so I'm going to add that to my n cubed column. Again, trying to keep track of those negatives. So now I'm ready to go ahead and add down the columns. 13n cubed minus 4n cubed. Well, 13 minus 4 is 9, and then I get n cubed. Well, this 3n squared has nothing to be added to, so I'm going to actually go ahead and just bring it on down to my final answer. 5n minus 7n is going to give me a negative 2n. So this right here is your final answer for number 8. I guess for you guys it's number 6. Okay, so let's take a look now at number 7. So for number 7, we're going to go ahead. Again, I'm going to change the signs of everything. Now notice that negative sign is negative 9 is going to become a positive 9 when I distribute in that negative. Distributing in the negative doesn't mean that everything becomes negative. It means you change the signs of everything. So for the first one, I have 5y squared minus 3y plus 8. So for the second one, I have a negative 4y squared, so I'll put that in the y squared column, and then I'm going to have a positive 9. So because I changed that, it's going to be a positive 9. So now I can go ahead and add down the columns. 5y squared minus 4y squared is y squared. Again, that 3y has nothing to be added to, so we're going to bring that negative 3y on down, and then 8 plus 9 is going to give us 17. So this right here is your final answer for number 9. Now let's take a look at number 10. Standard form is a little bit tricky with this one because we have that xy term. So let's just put our squared term first. So I'm going to do 3x squared. Then I'm going to put my combo term in the middle, and then my y term. And so there isn't really a definition of standard form right now when we're doing equation or expressions like these. Okay, so now let's line it up. So I changed it, so my 4x squared is now negative, so I have the negative 4x squared, and then I'm going to add the 2y, and then I'm going to subtract, oops, I want to put the 6y in that column. So I'm going to subtract the 6xy and then add the 2y, because that's what happened when I changed those signs. Well, 3x squared minus 4x squared is going to give me a negative x squared. Negative 8xy minus 6xy is going to give me a negative 14xy. And then negative 5y plus 2y is going to give me a negative 3y. And that is my final answer for number 10. Or I guess, again, for you guys, number 8. So let's take a look at number 9. So for number 9, the total number of public school teachers, T, consists of 2 groups, elementary E and secondary S. From 1992 through 2003, the number in thousands of secondary teachers and totals could be modeled by the following equation, where N is the number of years since 1992. So here, this represents the number of secondary teachers. This represents the total. So the total number of teachers is really just going to be the amount of secondary plus the amount of elementary. So for us to get the elementary, we need to take our total number of teachers and subtract our secondary. So that's what we're going to do with these two equations. I'm going to take my total number of teachers, and I'm going to subtract my secondary. And I'm subtracting everything in my secondary, which is why I put that parenthesis there. So I'm going to take this negative and distribute it in and change the signs. So then I have 58n minus 2,401. And then on the bottom, negative 29n. And then minus 949. And this should be a positive. I don't know where I got that crazy thing from. So then, when you're adding down the columns, 58n minus 29n is going to give you positive 29n. 2,401 minus 949 is going to give you 1,452. And so the number of elementary school teachers is going to be equal to that formula there. So that concludes your note video for today. Go ahead and get me your completed note sheet when you're done. Thanks for listening.